The last little piece that we're going to find is called a segment area. Okay, for segment area, it says a segment of a circle is like the portion between a chord and the outside of the circle. Now, we haven't talked about what a chord is yet, but a chord has two endpoints on the circle. So this line right there, that would be considered a chord. And a segment area is this little piece right here between that line and the circle itself. And we want to find the area of that piece. Now, you should probably color that in your packet because it's not highlighted in your packet. But that is the portion that we're finding for the segment area. So in order to do that, what we do is we take the sector area. Remember that we were able to find the sector area, and the formula for finding the sector area, okay, was to take the angle divided by 360, and we took that times the pi, the circle area formula, pi r squared. That was how we were calculating the sector area. Well, that's that whole piece right there. But we don't want that whole piece for the segment area. We don't need this triangle. So we're going to subtract the area of the triangle. And this came out of chapter 9. The area of a triangle is found by taking 1/2 base times height. So after we find the sector area, we just subtract the triangular piece that we don't need, and we're left with this little section right there. So in this case, you don't see a degree given out here, but you do have the box in here, so that means the central angle is 90 degrees. So that means that this out here is 90 degrees. So they put 90 over 360 times pi times the radius squared. The radius was 8, so 8 squared is 64. So they did that section of it right there, and if you reduce this down, this becomes 1/4. Okay, if you cancel out the zeros, 9 over 36 becomes 1/4, and 1/4 of 64 is 16 pi. And then the rest of it, this portion of it, is we are subtracting the area of this triangle. Well, 1/2 the base and the height. The base and the height are the same. They're both radii of the circle. So they're both 8. So base times height is 64, and 1/2 of 64 is 32. Now when you get down to this point, you cannot subtract 32 from 16 pi. Because 16 has pi in it, you cannot subtract a number that doesn't have pi with it from it. So we could just leave our answer like that. Or if you wanted to plug in 3.14 here, 16 times 3.14, then you could subtract 32. Okay, let's try another one. Okay, and again, they don't do a great job here of showing you what you're finding, but the segment area would be this right here, this piece. So we want to start out and we want to find the sector area, so we're finding this whole thing. So the degree is 120 over 360, and we're taking it times the radius. The radius would be 12 squared. So this portion of the formula right there is the sector area. 120 over 360 reduces down to 1/3. 1/3 of 144 is actually 48. So we get 48 pi out of that sector area. Now we want to subtract the triangle. If you look at the triangular piece, okay, your base and your height. Here's your height. Okay, this triangle right here. The base is the 21. Even though that's not the side that you're visualizing it sitting on, that's the base is 21, and then the height is that 6. So here's base times height. The radius of the circle is not the base or the height of this particular triangle. So be careful with that. The base is 21, the height is 6. So when I multiply those together and I take half of that, I get 63. So I'd say the area of this portion right here, just this piece of that circle, is 48 pi minus 63. Okay, and let's try one on our own here. Okay, I can see that this is 90 degrees, or you might see a box there, but I would take 90 over 360, and I take that times the area of the whole circle, so that would be times pi times the radius, 6 squared. And I'm going to subtract the triangle here. I don't want this piece. That's not part of what's shaded. So the triangle formula is 1/2 the base. Okay, this would be the base. Well, if the radius is 6, this is a radius too. So it would be 6, and the height is a radius, so 6 times 6. 90 over 360 reduces down to 1/4 times pi. 6 squared is 36. Minus, this would be 1/2 times 36. Okay, 1/4, I can do this multiplying. 1/4 of 36 would be 9 pi minus, and then over here, half of 36 would be 18. So I would say that that area of this little dark piece is 9 pi minus 18. Okay, and that's how you find segment area. Okay, and the other thing that's on your worksheet is what's called an annulus area. Okay, an annulus area, think about it, if I think about it as a donut, or I think about it as a washer, see a bolt and a washer, this is what a washer would look like. And we're just trying to find the area of the shaded, the dark piece. It says an annulus of a circle is a ring, a circle with a circular center cut out like a donut. To find its area, we're going to subtract the area of the smaller circle from the area of the larger circle. Okay, so we want to start with the large circle. This would be the outside right here. If I can find the area of that whole thing, okay, and again, area of a circle is pi times radius squared. And they're going to use a capital R for the large circle, so pi times radius squared. Now, the radius of the big circle starts in the center here, and it goes all the way out to the outside. So we have to add those two distances together. So I'd say pi times 12 squared. And then minus, I'm going to subtract the area of this inside circle. I want to subtract this piece right here because it's not part, it's cut out. It's not what I want. It's not shaded. So I'm going to say pi times the radius of just the inside piece is 5. Okay, so I've got 12 squared would be 144 pi minus 5 squared would be 25 pi. Now with these two, you can subtract those two because they both have pi in them. So if you take 144 and you subtract 25, you're going to get 119 pi. And it's an area, so we would say centimeters squared. Okay, and then the last example here, it says find the area of an annulus formed by two concentric circles where the radius of the outer circle is 9 and the radius of the inner circle is 7. Okay, so again, when I'm using that formula, I want to take the area of the big circle, the outside circle, which is 9. It's got a radius of 9. And I'm going to subtract the area of the inside circle, the smaller circle. So that would be pi times 7 squared. 81 pi minus, this would be 49 pi. So we got to take 81 and we got to subtract 49. That would be 32 pi. And it would be centimeters squared because, again, it's an area. So if you think of the annulus, you're taking that outside big circle, starting with that, find the area of that, and then subtract the inside circle, the little one that you don't want. Okay, that's how you find the annulus area.